Hello everyone, welcome to this video. In this video, we will see the question longest consecutive sequence. So given an unsorted array of integers, find the length of the longest consecutive elements sequence. So consecutive elements means like we are given 1. So next element should be 2, 3, 4 and similarly it will be increasing by 1. So that is like x plus 1, x plus 2, x plus 3 and so on. So that are consecutive elements. So in this array like we are given consecutive elements are 1, 2, 3 and 4. These are increasing by one element, one number each. So basically these are the consecutive elements, and the sequence is different from the substring or like that. Sequence is basically we are like allowed to choose any element that their index should not be like together, like 1 plus like they should not be consecutive. The like this is the sequence like 4, 1, 3, 2. They are not occurring together, like 200 is between them, so that is a sequence. We are not bounded to search the elements in the index corrected. So we will see three approaches for this question. The first approach will be the naive approach. So naive approach, basically we have to initialize three loops. One loop will be iterating over the one element for whole array, that will be n times. So the second loop will be for that element we are searching for the consecutive elements. If like 100 is there, so we are searching 100 and 100 and 200 and 3. Second loop will do that, and third loop will search if that element is there in the array or not. Will be a lookup for lookup of the consecutive elements. So I have written that one loop will be iterating of the whole array one by one, and second loop will be iterating for the element selected by first loop, and the third loop will for lookup for the consecutive elements of the current element. If the interviewer asks you this question, so you should start with the brute force approach that is using the three loops. One loop will be used for iterating of the whole array elements, and the second loop for the finding the consecutive elements, and third loop for searching if they are present in the lookup table or not. So that was it, and it will take n cube time and O1 extra space. So space is good, but time is really not acceptable. So we have a better approach, that is using sorting. So if we sort the basically if sorting comes in the solution, it means there will be n log n solution. So we have n log n time solution, and it will take on or O1 space accordingly. If you use merge sort, it will take On. If you use quick sort or an in-place sorting algorithm, so it will use O1. So this is it. So in this solution we have to first sort the array. Once we sort the array, so you can see all the consecutive elements will occur together, like 1, 2, 3, they are all occurring together. So we have just to count the maximum length of the repeating of the consecutive elements. So then we will iterate over the array, and we will maintain current max and result final result, and current max will be used for like current element we are searching the consecutive elements. So current max will keep the count of the consecutive element for the particular element if it exists. So if it is 1, so current max will increase. Like for next element we will check if the I plus 1 index is plus 1, so yes, 1 plus 1 2, yes. Next index element is 2, yes. Next index element is 3, so yes, it is 2. So when we reach here like 4, then we will check if it is not equal to 5. Yeah, 100 is not equal to 5, so we will see update the result. Then we will update the result will be is equal to max of the result, the previous result, or the current max that we have found. So that will be it. So that will be so like that. So if the next element is not consecutive, we will then again change the current max to 1, because we have to, if for 100 we have to start with 1 again, because current max is keeping count of the temporary that element. So we will keep our result in the final result variable, and we will return the result. So it will take n log n time, because we have to sort the array, and we can do it better by compromising our space complexity, and we can like decrease our time complexity. We can make it on, and the space will become on. So basically in this solution we will use hashing, or you can say set. So basically set is a data structure which stores only the unique elements. You would have studied it in your elementary classes, or sorry, in 12th or 11th classes or 10th class also. Set. So set basically shows only the unique elements. So we will use a set for this solution. So we are given a solution that question that is 100, 4, 200, 1, 3 and 2. It is similar. So output will be 4, because of the consecutive sequence will be 1, 2, 3 and 4. So we have to first of all store all the elements in the set. So we will add all the elements of the array in the set. So this is our okay set. So we can use a 2 also in here if it is if it is duplicate. So for this step we will have a set that will have values that are 1, Okay, so it will be in any order 4, 3, 2, 100 and 200. Okay, so you would be thinking that I have not written 2 here, so because I have told you that set only stores a unique element, so only 1 2 will be stored, not the other one. So we have initialized a result variable for where we will store our maximum result that we have found to return that. So now we have to iterate. It will basically take 2 iterations, 2 n time, so it will be 2n complexity precisely. So now we have to iterate over the whole array, and we will check if the, so I will basically dry run this code and show you how it works, so you will understand it easily then. So if we are at this index, first of all I will write the elements also. So we have the array that is like index, so we will have to iterate from this. First our I will be here, so we will check if I array of that, so array of the a of I that is 0 is basically 100, so 100 minus 1 that is 99. 99 is there in this the sub array or this set, so no, 99 is not present, so we will enter into this loop. So check if the previous value of the current value exists or not. Basically we are doing this, I will show you at the end why we are doing this. So now we will enter this loop and our current will be initialized to, so 1, so the current is 1. So now we will check while a of I plus current in this set. So yes, so we'll first of all check a of I that is 100, 100, okay, 100 plus 1, current is 1 in set, 100 and 1 is not in set, you can see it is not present in set, so this condition is not true. So we will again come to this and we will check if result, so we will update the result. So basically the result is 0, so we'll check result maximum of like 1 and 0 is 0 or 1, so we will initialize our result to 1 or like set our result to 1. So now we'll come to this element that is 4. So I will come here and we will check if a of I minus 1 not in the set, so 4 minus 1 in set, yes it is there. So we will not enter in this loop because we have to enter when we reach the starting element, that is there is an element before 4 that is present in the array, that is 3 is present in the array. So we will not iterate, we will not run into this condition for the 4 because we know that there is an element before 4, so that would be our starting element. So we will skip this. Now it will come here, result will stay same, so we have not entered this condition. So now 200, we have came 200. Now we'll check if 200 minus 1 not in array, yes it is not in the set, so this is basically our starting element. Yeah, this is starting element, that is 199 is starting element. We will check current is equal to 1 and we will add this, so sorry, we will add 200 plus 1, so that is 201, and we will check while a of I that is 200 plus 1 in set, so it is not in the set, so 201 is not in the set, so this condition will be false, so it will not run. So we will check if result, we will update the result, so maximum result is 1 and current is also 1, so maximum of 1 and 1 is 1, so result will stay 1. I will write the result here, okay, so it will be 1 again. So now I will iterate to the next element, that is 1, so we will now come to 1 and we will check if 1 I minus a of I minus 1 that is 1 minus 1 that is 0 in set, no it is not in the set, so 1 is the starting element for our consecutive sequence that we are searching for. Maybe it can be potential like starting element, so we will enter into this condition, okay, because the previous value is not there. So we will initialize current to 1 again and we will check if a of I that is 1 plus current that is 1 is equal to in the set, yes it is there in the set. So basically we are using set because it takes only O1 time to search the element, so it is fast. So in C++ we use unordered set because it is more faster than the ordered set. So this will be our, yes this is true, so we will now increment our current variable to 2 plus 1, so current will become 2. Now we will check if I plus 2, that is 3 in the set. So yes, 3 is also in the set, so we will be searching for this in the set in this condition. So yes, it is there, so we will increment our current to 3. Okay, current will be incremented. Now we will again check, we will again come to this condition, and a of I plus current, that is 1 plus 3, that is 4 in set. So yes, 4 is also present in the set, so now we will again increment our current will become 4. Now we will check if a of I, that is 4, a of I 1 plus 4 is equal to 5. 5 in set? No, 5 is not there in set. So finally we will come out of this condition. So now we will set our result to max of result or current. So our result is 1. Our previous result was 1. So the current result is 4. So we will initialize the result. We will set the result to the maximum of both. So maximum is current value, that is 4. So now our result will be 4. So this is how we are like iterating. So now again I will come to the next index, that is 3. So this element. So now we will check if a of I minus 1 not in the set. So I minus a of I, that is 3 minus 1. 3 minus 1 is in 2. So yes, it is in 2. 3 minus 1. 2 is in the set, so we will not enter into this condition. So basically this condition is to avoid checking the elements again who have been included in the consecutive sequence. So this is why we are using this condition. So similarly it will again come to the 2. So 2 minus 1 is in the array or set, that is 1. So we will again not enter into this condition. So this was how we are using a set. First of all, we are adding the elements in the set, then we are initializing a result variable, then we are checking if the element is not the starting, if element is not in between the consecutive subsequence. So basically if it is a starting of the sequence, so then only we are initializing this current variable, and we are finding the next elements and updating the result variable. So that was it. Now I will show you the solution on the Leetcode platform. So I've written the code in C++. So this question is basically rated hard, so it is not that much harder, I would say. So I have written the code in C++, you can see. So basically I have used an unordered set. So we have initialized unordered set S, and the answer or the final variable that we have to return, and we are first of all inserting the elements one by one in the set. So basically insert function inserts the element in the set. So we are done inserting elements over here. So I will also share the code in the description, so you can check the code from there for the reference. Now we will iterate for the final loop, that is for I is equal to 0, I less than numbers, okay, dot size. So now we'll check if I will first of all clear that s dot end is basically if element does not exist. So in C++, if s dot find that number we are searching for does not exist, so it will point to the end of the array. So this means that array element is not in the set. So okay, so I have explained you this in this syntax. This is similar. It is easier because it is written in Python, so you can understand that. So we have initialized our current variable, and we will search if the next element, that is the consecutive element that is increased by 1 is in the set, then we will increase our current variable. And when we reach an element whose next element is not there in the set, then we will set our answer to the maximum of the previous answer and the current result that we have got. So at last I've shown you the dry run of the code, so it will run accordingly, and then we will return the result variable. So I will see if the code works. We will run the code now and submit the solution and see. Okay, so it has run. So now we'll submit the solution. So I've previously submitted these solutions. So yeah, it ran, and it took actually took less time than previously. So it is faster than 99.21% solutions in C++, and it takes less memory than 61.92 solutions. It is taking more memory because of the set we are using, so it takes O of n time, okay, and O of n space. So this was it. Thank you guys. If you do like this video, then do like, share, and do subscribe this channel, and comment down below for more videos, the programming questions that you want, and help me further giving your reviews, so I can improve my video qualities and explanation skills. Thank you guys. Thank you for watching. Do like this video.